Hello viewers, you are welcome to the Don's Consult, where we bring you chemistry questions and simplify them. At the Don Consult, we make chemistry very simple. Today I have a question for you, a question on quantum numbers. So let's see it together. The question says, list the quantum numbers, that should be quantum numbers. List the quantum numbers that are assigned to an electron in an atom. The next one says, what is the maximum number of electrons that can occupy the 3d orbital? The next one, the B part says, an element represented as P has the following electronic configuration, which is 1s2, 2s2, 2p6 and 3s2. Now say question 1, write the electronic configuration of the ion of P. The next one says, without identifying P, write a possible compound of its chloride. Alright, so let's see how it goes. Very simple question. For those of you just starting chemistry, this is one of the rudimentary topics you are going to be taught. And for those of you that are far into it, you have been taught this in the past. So if you have forgotten, let's remind ourselves. And if not, learn. Okay? Alright, don't forget to recommend this page to your friends and to whoever that you think needs it. And of course, this video, please like, comment and share. Thank you. So now this says list the quantum numbers that are assigned to an electron in an atom. I've made a video of quantum numbers, so if you didn't see that video, you can you can go and check, and maybe I will still do one more that will explain them into details. Okay, but for this one now, said we should list the quantum numbers that are assigned to an electron. The quantum number assigned to electrons, we have about 4 of them. We have one called azimuthal quantum number. Azimuthal quantum number, which is represented with letter L. We have another one, which is what is it called? Principal quantum number. All right, which is represented with letter N. Okay. All right, we have another one called magnetic quantum number. Magnetic quantum number, which is represented with letter ML. All right, and we have the last one, which is called spin quantum number, and that is represented with letter MS. These are the quantum numbers that are assigned to an electron. All right. Okay, now the next question will say, what is the maximum number of electrons that can occupy the 3d orbital? You know that in the orbital energy level, we have the S, P, D, and F. And this one contains maximum number of 2 electrons. P contains maximum number of 6 electrons. D contains maximum number of 10 electrons. F contains maximum number of 14 electrons. How do you know? Because this one has 1 energy level. P will have 3 energy levels. D will have 5 energy levels. Alright, and this one will have 7 energy levels. 1, 2, 3, 4, 5, 6, 7 energy levels. So now they say in 3D, either 3D, 4D, however D they put the maximum number of electrons any d orbital can contain is 10 electrons. Alright, 10 electrons. So the answer there is 10 electrons. Okay, I just use this one to explain, okay, for your proper understanding. Okay, the next one says an element represented as P has the following electronic configuration. We are given this electronic configuration. It says write the electronic configuration of the ion of P. When we say ion has to do with an element that is charged. Element that is charged. It's either is positively charged or it is negatively charged. Is that right? And depends on the outer valence electrons to determine if it's positive or negative, because we know that element with 1 to 3 electrons at the valence shell will donate. and when they donate they become positively charged. And those one that has 5 to 7, that have 5 to 7, we accept, and when they accept they will be negatively charged. So let's see this now. 1s2, this one is 1s2 2. So if I go to put this one in shell, the first shell will have maximum number of 2 electrons, we know, and second and above will have 8 electrons, so we have 2 8, and there will be what, 2. So there will be 2 electrons at the valence shell. All right, so this valence shell will be readily given out from what I've explained here. So it's going to, so P and ion of P will be 2 plus, will be like this, 2 plus. That means 2 electrons will be given off. So they are asked to write the electronic configuration of this. So when you have 2 plus, that means 2 electrons have been given off, have been donated. So we're going to have 1s2, 2s2, and 2p6. Or if you want to put it in shells, it should just be 2 8 in shells. All right, hope we are following. Okay, so the last one says, without identifying P, write a possible compound of its chloride. What do you mean by chloride? Chloride has to do with chlorine that ionize. So I say possible number of P. Now look at it now. P has this one. Now the valency of this chlorine is -1. The valency of P, because of this 2 plus here, because when it ionizes now, will be what? +2. So now we want to make the ions. If you want to do it now, P has 2, Cl has 1. Okay, so when they will exchange their valencies, P will have 1, it will be P, and chlorine will collect the valency of, following this one, will collect the valency of P. So this will be the possible compound of its chloride. That is how simple chemistry can be, and that is what we do here at the Dawn's Consult. Partner with us as you prepare for your exams. We are here to make chemistry very simple so that you can come out with flying colors. All right, thank you. See you in the next video.